All right, let's jump right into one of the most incredible matchups on the planet. We're talking about a true collision of titans, a meeting of two of Earth's most powerful, most primal forces. So what actually happens when the searing heat of molten rock slams into the frozen ancient stillness of a glacier? I'll tell you this, it's not just some pretty light show. It's a process that can completely reshape a landscape, sometimes in just a matter of minutes.
So to really wrap your head around this, you've got to appreciate the sheer scale of the temperature clash. I mean, on one side, you've got molten lava, we're talking up to 1200 degrees Celsius, and on the other, ancient glacial ice, often sitting well below minus 15 degrees. Do the math, that's a temperature gap of over 1,000 degrees. And you can probably guess, when these two extremes finally meet, the reaction is, well, let's just say it's anything but gentle.
So that's the big question, right? What really goes down in that violent, immediate moment of contact? Does one side just win? Does the fire melt the ice, or does the ice cool the fire? Or do they create something completely new and unexpected? Well, let's break it all down.
Okay, so the very first thing that happens, the instant these two forces touch, is something called thermal shock. And really, it's exactly what it sounds like, the immediate physical consequence of that insane temperature difference.
Yeah, that 1,000-degree gap, it's way more than just a number on a chart. It's the trigger. It's what unleashes an absolutely incredible amount of energy. The lava doesn't just, gently melt the ice. No way. It causes an instantaneous, violent reaction, completely overwhelming the glacier with pure, raw heat.
And get this is what really shows you the power imbalance here. We are not talking about a slow, gentle thaw. A single cubic meter of lava, think about something the size of your washing machine. It holds enough raw energy to flash melt many cubic meters of solid ice almost instantly. And that crazy fast energy transfer? Well, that's the fuse, and it's about to light a much, much bigger explosion.
And that brings us to the really explosive part of the story. Because, see, when you flash melt all that ice, you obviously get a ton of water. But when that water immediately meets 1,200-degree lava, well, it becomes a weapon.
Now, this has a pretty intense scientific name, a Phreatomagmatic explosion. Yeah, it sounds complicated, but don't let the name fool you. The core idea is actually pretty simple. It's an eruption that gets its explosive punch not just from the magma itself, but from the super violent interaction between that magma and water.
So let's walk through how this happens, step by step. First, lava makes contact with the ice. Simple enough. But then, that ice instantly becomes water. But it's superheated, trapped right up against the molten rock. And then, and this is the critical part, that trapped water flashes to steam, expanding its volume by over 1,000 times in a split second. The force of that expansion is just immense. It's so powerful it literally shatters the cooling lava into tiny pieces of ash and volcanic glass.
But believe it or not, the chaos doesn't stop there. See, when an eruption happens underneath a glacier, all of that meltwater can get trapped, building up in this massive hidden lake beneath the ice. And eventually, when the pressure gets to be too much, that ice dam breaks, and that unleashes something called a jökulhlaup, which is basically a catastrophic glacial outburst flood.
And let me be clear, these are not your average floods. A jökulhlaup can release water at a rate that's actually comparable to the entire Amazon River. And it's not just water, it's carrying huge icebergs, boulders, all sorts of volcanic debris with it. These things are easily one of the most powerful and destructive events in nature, a true force of, well, liquid demolition.
Okay, so we've talked a lot about destruction, but here's the amazing part. Out of all that violent chaos, new land is actually born. This incredible encounter doesn't just destroy, it creates. It forges entirely unique geological features you just can't find anywhere else on the planet.
So just picture this for a second. Imagine a volcano trying to erupt, but it's completely trapped, buried underneath a kilometer-thick sheet of solid ice. It has nowhere to go sideways, so it can only go one way, straight up. What kind of bizarre mountain do you think that would create?
Well, the answer is something called a tuya. The immense weight and pressure of the glacier basically acts like a giant mold. It forces all that erupting lava to build straight up inside these ice walls. The result? A volcano with this really distinct flat top and incredibly steep, almost vertical sides. There's really nothing else like it.
And here's the coolest part. A tuya isn't just a weird-looking mountain. It's a geological time capsule. Its flat, table-like top tells you exactly where the eruption finally broke through the surface of the ancient ice sheet. Those steep sides, They're basically the ghosts of the ice walls that once held it in. So when geologists find one of these, it tells them precisely how thick the glaciers were in that exact spot thousands and thousands of years ago.
And if you look closely at these tuyas, or anywhere the lava flowed into those pockets of meltwater, you find this stuff, pillow lava. These weird, bulbous, pillow-like shapes form when lava cools almost instantly in water. Now normally, you only find this stuff deep on the ocean floor, so when you find it high up on a mountain, that's a dead giveaway. It's a crystal clear sign that a massive glacier was once sitting right there, providing all the water needed to make it.
Okay, so let's zoom out for a minute. The impact of these incredible encounters goes way beyond just the local landscape. This whole clash of fire and ice, it actually has global consequences. It creates unique ecosystems and, get this, it even gives us clues in the search for life on other planets. Hey, remember those jökulhlaups we talked about, those massive floods? Well, imagine dumping that much cold, fresh water into the ocean all at once. It can actually disrupt the delicate balance of our global ocean currents, the very things that drive our planet's climate. So an eruption under a glacier in Iceland could literally affect weather patterns thousands of miles away. It's all connected.
But here's the flip side. Those same phreatomagmatic explosions, they are incredibly good at blasting superfine ash high up into the atmosphere. And that ash can just hang out up there for years, reflecting sunlight back into space and actually causing a temporary cooling effect on the whole planet. So you have this amazing duality, right? A single event that has the power to both mess with warming currents and cause cooling.
Okay, but now this is where things get really fascinating for me. Think about what we have here. You've got heat from the volcano, you've got water from the ice, and you've got a rich supply of minerals from all that fresh volcanic rock. In one of the most extreme environments on Earth, could that be the perfect recipe for life? And maybe, just maybe, could it be a blueprint for how life gets started beyond our own planet?
The answer seems to be yes, absolutely. These fire and ice zones on our own planet create these incredible little hotspots for microbial life. There are these organisms called extremophiles that don't just survive in these insane conditions, they actually thrive in them. That's why scientists are so obsessed with studying places like Mount Erebus in Antarctica. It's an active volcano completely covered in ice. They see it as a perfect model, a modern-day testbed for what we might find on Mars, or even on Jupiter's icy moon Europa, which we think has a huge liquid ocean hiding right under its ice shell.
And at the end of the day, that's really what this whole story is about. It's just a perfect expression of how dynamic and complex our planet is. You've got this constant battle of competing forces. Heat versus cold, creation versus destruction, stability versus chaos. It's this incredible dance that is constantly reshaping our world.
So yeah, the meeting of fire and ice, it's carved entire landscapes, it's altered global climates, and it's given us a potential blueprint for finding life out there in the cosmos. It really just leaves you wondering, doesn't it? In the most remote, most extreme corners of our own planet, what other secrets are still hidden, locked away, just waiting to be discovered, right where fire meets ice?